Have you ever wondered how autonomous vehicles work, or how street cameras can identify criminals by their face?
That box. So there is a warning to the police station.
This is a technology called computer vision. Hi there, welcome to STEM Playground 2021. My name is Steven, and me and my partner Lek Yang will be building a project called Face Tracker using OpenCV and Arduino. Now, let us talk a little bit about OpenCV. So, what is OpenCV? OpenCV was originally developed by Intel. It is an open source computer vision library. And who inside Intel developed OpenCV? It was Dr. Gary Bradsky, which at the current time is an Intel employee. So he came up with this idea of computer vision library, which he named it OpenCV. And now he is the founder and president of OpenCV. OpenCV was later supported by Willow Garage and itsys, which was later acquired by Intel. And now OpenCV is free to use under open source license Apache 2. And now let us talk a little bit about what are the achievements of OpenCV. OpenCV had 54k stars on GitHub, which is a very popular repository website where you can build your own portfolio. It was installed 1 to 2 million per week, which rivals TensorFlow. And then, it is the most popular computer vision library among embedded vision engineers. Lastly, it has the largest collection of computer vision algorithms in a single library, totaling up to 2,500 algorithms. And now let us see a little bit on the demos of the project. First, let us start with Lek Yang part, then we move to my part. Okay, so now we can see that the webcam is working with the code in the backend. So now it is tracking my face, and as shown here, you can see that it is now moving to the right to track our face. Okay, so now let us look at the close-up view. Okay, as we can see here, I added the face recognizer to the project, which the reference project didn't have. And we can see sometimes it recognizes me as Nicolaj, which is not true. This is because this is not a deep learning model, and it can definitely be improved through a deep learning model. And of course, I want to thank my friend for the lightning help. So now let us go to the code part. Okay, so we are now at the foundation of every hardware, which is the code. Okay, so let us start with the face train part. As we can see here, okay, first we need to import the CV2 library, right? And then we need to import the picker package too. This is the picker library. This is actually a Python library to pack and unpack data. Okay, so here this part is basically the picker library code. Okay, and then here we are saying that the face recognizer, this is the CV2 code, CV2 library code, the face classifier. This is the location, right? So we are saying that it is in the hard cascade classifier folder, and then the file name is hard cascade frontal face, which is here. This is the folder, right? As you can see here, hard cascade classifier. So data. So this is the file name, frontal face aot.xml file. We can also use the alternative file. It will be the same. Anything can work. Okay. So next, we move on. So this is the face to recognize the CV2 code. Okay. So here we are creating a set, right? We are creating a set for it to store the data into. Okay. And here we are saying that anything with PNG, JPEG, or capital PNG is the file that we are going to learn. We are going to learn how to recognize the face. Okay, and then here is the image folder. Okay, this is the image folder. As you can see here, this is my face, and then here is what we saw, Nicolaj, and then here this picker library I learned from Justin. All right, so this is face. He's in YouTube. Okay, let's move on. So here we are converting the image into grayscale. Okay, L is the grayscale for pure image. Let me see. Here, right? Here, as we can see here, L, the second paragraph, L is the third paragraph. L is grayscale, all right? Mode L is grayscale. Okay, and then we are changing the image file, image size into 300 by 300 pixel. This is why, because if the file size is not, the image size is not consistent, sometimes the data is not too accurate. And then lastly, we are converting the file type into UINT8, and then we are storing it in array form, which is into the set of this label ID. Okay, and here we are saying that our region of interest, all right, it is just a y plus h, x plus w, which means that, right, is this part. So y in the y direction, y plus height on this part, which is the defined in the face, the main code, and then x plus width, just this small part. Okay, and then lastly we are packaging, right, the data into this into label ID. All right, they call it dump, but it's like a package, and then we are storing it as a train face.yml file. Okay, it can be seen here, right? This one, train face.yml file. Okay, let's move on. And this is the main part, right? We are doing the same, right? We are importing numpy, importing CV2, importing picker, and then this part. This part is actually for us to convey the data to the Arduino, or we can say we are sending the data to the Arduino. Okay, so here we are defining a function which is called a 720p. We are setting the width to be this width. This is correct. We are setting the width to be 1280, the height 720. This is like the specific number for the OpenCV library to define width and height. So here, this is the main part, right? We are saying that the classifier, this is the main part to recognize the face. And then we are saying it is in the frontal face, okay? The same part. This is also the OpenCV library code. Then we are saying that read the train face YAML data, all right? And then here we are specifying the COM tree of the Arduino, all right? This is we can see from the in the Arduino ID face later, okay? And then this part, they are is saying the sleep is delay execution for given number of seconds, okay? And it's set to 1, which is doesn't really understand too. Okay, let's move on. So here we are saying that we are loading the data, picker load. All right, this part, okay, we are saying that we are outputting, or we are capturing the video which is from the webcam. All right, and then one means that is an external webcam. All right, and then 0 means that is the default webcam on your laptop. And then here we are saying we are changing the frame to 720p. And then this one is to make the frame keep on opening while true, or you can say while 1 or something like that. And then here, all right, and then it says mirror. And then here we are, for the previous part, right, why we are changing it to grayscale? Because if we are doing it in RGB mode, it has a lot of information, right? So it is maybe you can say that the train data would be bigger and then more complex. So that is why we are changing it to grayscale first, so that it has less data and easier to recognize. So here we are changing the color to BGR, which means blue, green, red. OpenCV use BGR. Well, usually we saw is RGB, but OpenCV is doing quite differently. And then here it says that detect multi-scale, right? This one, this one, if we can go back here, right? Detect multi-scale. It gets scale factor equal to 1.5 and then minimum neighbor equal to 5. This one is actually their library also, which sometimes with a scale factor. Yeah, it says that scale factor is parameter specifying how much the image size is reduced. Minimum neighbor parameter specifying how many neighbor each candidate rectangle should have to retain it. Yeah, this one is also we need to dive a little bit deeper, like by ourselves through Google. Okay. Oops. Here is the part. Okay, so here, same, the region of interest of the gray is just x, y plus h, x plus w, just like in the previous part, right? This is the region of interest. And then here we are drawing a frame to saying that this is the face, all right? And then so here x plus w, y plus h, and then this part, like what we mentioned before is blue, green, red, right? And then 255 is actually the highest value, which means you can say is the uh, bluest, reddest, right? So here you can see that blue is 255, green is 255, and then red is 0. So blue plus green, you can say we get something like turquoise, right? Turquoise, this color. Okay. And then this is the width of the stroke, the triangle line. Okay, here's doing the same. And then here, okay, here it says, here is the to output the name part. It says that if the confidence level is more than 30%, print the ID, right? Show the name, which the name is the folder of the image. Okay. Okay, and then here it says show it in white color, right? So if everything is max is white color, and then the width of the text is 2. Okay, and then it says put at the frame, right? So here it output the frame as frame, the name of the frame which we saw it in the previous video. And then, or I can show it later too. And then here we are saying that press P to release or to close down the frame window. Okay, so let us, and then, okay, now we go to the Arduino part. Okay, we are importing the servo library. We are saying that the width of the frame is this. And then here we are specifying the initial servo motor, the rotation, which is at 90 degree. Yes, okay, we are attaching the X servo motor to be in the pin 3. X, which means if we are looking at here, we can see that the X is something like this part, right? This is the X, and then this would be the Y, okay? So here, and then lastly, they are writing the position of X and Y, which later we can see. Here, it is saying that for every movement, the face is not in the rectangle part. Spin the servo motor by 1 degree. Okay, and then it says read. We are sending the middle location of the face, right? The center of the face, which is here, here. We are saying that this is the center. This is the center, which is x plus w divided by 2, and then y plus w divided by 2, right? And then we are writing this center to the Arduino, this part. Okay, we are printing the data to the Arduino, and then we are encoding it in UTF-8 format. All right, so what is this? It is actually, yeah, UTF-8. It is a variable for encoding used for electronic communication. Okay, so here we are saying that if the frame, right, is more, it moves more than 30, I believe this is pixel or width, all right? So like just now is 120, something like that. So if you move by 30, this one, change the angle by 1. You can see here, right? Okay, and then this one is the same, just in reverse direction. This one is Y. And then here we are limiting the rotation of the servo because we are using a 180-degree servo. So if you are using 360, I believe this wouldn't be any issue. So here we are just limiting. If it's over 180, fix it at 180. If it's less than 0, fix it at 0. Lastly, we are writing the position, which we can see later. Okay, give me a while. Okay, so we can see here, right? This is the part where we say frame. The frame is here. And then, because I'm then lighting issue is not too good. Okay, so we can see. Okay, with that. So you can see when it's doing that, here it is outputting. See, yeah, this is why this is the part where the X and Y pose. Okay. Yeah, so this that's basically it, right? This is the bone of everything, right? And then yeah, so I want to thank you for your time and attention, and I wish that all of us can be better. Okay, so wish us all the best. Thank you. Lastly, you can screenshot or snap a picture from a camera or scan this QR GitHub code first, and then to learn more about the project. So I pause for 5 seconds here. Yeah, so I want to thank you for your time and attention once more, and let us keep on improving. So thank you.
僕たちは燃え盛る旅の途中